Well, hello and welcome. In this video, I'll be covering section 1.1, which is over the Cartesian plane and the distance formula. My goal for you by the end of the video is to be able to plot points in the coordinate plane, as well as read data presented graphically, to be able to find the distance between 2 points in a coordinate plane, and to be able to find midpoints of line segments connecting 2 points. So what is the Cartesian plane? Well, it's essentially just another name for the rectangular coordinate system. Something that maybe you guys just like to call a graphing grid. The plane is formed whenever you have two intersecting real number lines that meet at a right angle. And the two names of those real number lines, we have the horizontal one, which would end up being what we call the x-axis, and the vertical one, which we would end up calling the y-axis. Where those two axes meet, we like to call that the origin and represent it with the ordered pair 0, 0. The axes also do subdivide our plane into 4 parts that we like to call quadrants and are numbered in a specific way that we'll see on the next slide. Every single point that we have on this coordinate system is something that is able to be represented by a thing called an ordered pair, where we always have our x value first, followed by our y value second, where that x coordinate that we have is always representing our directed distance from the y-axis, and the y coordinate is always the directed distance from the x-axis. So just think horizontal for the x value and vertical for the y value. Now, as you can see with this, we have our quadrants labeled. The first quadrant is always going to be in the top right, where everything is positive, or where both x and y are positive. And then it just goes counterclockwise around. So top left would be our second quadrant, bottom left would be our third quadrant, and bottom right is our fourth quadrant. And for those that remember anything about the unit circle, it's essentially you go through the quadrants the exact same way as you go through positive angles, if that helps for you to remember. So let's try a few examples of just plotting points. So if I wanted to maybe give these some names, A, B, and C, so they can be labeled once I get done. If I needed to do A, it says I need to go horizontally 3, and it's positive, so it would be specifically to the right. So the directed distance right 3, followed by the directed distance up 1. And once I get to that intersection point, I just go ahead and label it with a dot and whatever its name is. So let's go on to B. I need to do a horizontal directed distance of -5, so that would be left 5, and a vertical directed distance of +3, so up 3. Again, plot the point and label. One more example, -3, -4 would be a horizontal directed distance towards -3, so left 3, and a vertical directed distance of -4 or down 4. And that would end up here in the third quadrant. So again, we plot the point where that intersects and go ahead and label it. Now moving on to the next topic, we'll talk about the distance formula. So the distance formula between 2 points, we'll just use x1, y1 to represent the first point, and x2, y2 to represent the second point that happen to lie in this Cartesian plane. I end up to finding, or to be able to find the distance, I end up just needing to subtract my 2 x values, square the result, and add it with the 2 y values subtracted, or the difference of the 2 y values. So sometimes you might see in a book they would just represent this with a delta x, or change in x, and then the other one, change in y. So if you ever see that triangle symbol, that usually is going to be able to be read out loud by saying the word delta, or you can also say it's the change. So let's go ahead and try an example of this. If I want to find the distance between the points -2, 1 and 2, 4, I'd first set up my radical, and then it's just going to be the 2 x values subtracted, so 2 minus a -2, quantity squared, added with my 2 y values subtracted, so 4 minus 1, quantity squared. At this point now I go ahead and simplify each of those, so I've got 2 take away a -2, that would really turn into 2 plus 2, so that would be 4 squared. 4 take away 1, that would be 3 squared. If I go ahead and simplify those two powers, 4 squared would give me 16, 3 squared would give me 9. If I add those two together, I get 25, And that's kind of nice that that came out as a nice number to take a square root of, so the distance between those 2 points would be 5 units. And now on to our last topic, which is the midpoint formula. So to find the midpoint of a segment that joins 2 points, x1, y1, and x2, y2, in our Cartesian plane, ultimately what we do is we just find the average of our x values and our average of our y values. Again, key word here is it's a point, so I represent it as an ordered pair. So there will always be parentheses, and there should always be 2 numbers inside separated by a comma. So let's try an example here. Find the midpoint of the line segment that joins these 2 points. So our midpoint for this is going to be the 2 x values added together. So -6 plus a 2 divided by 2. And that's going to be paired with our 2 y values added together and divided by 2. So if I go ahead and simplify each of those, -6 plus 2 would be -4, and then -4 divided by 2 would be a -2. And 2 plus 9 would be 11, and 11 divided by 2 doesn't reduce, so I'll just leave that as the fraction 11 halves. So the midpoint between those two must be this -2, 11 halves. So I know this video has been a pretty short and quick one. Hopefully this has just been review for you guys, remembering how to plot points, finding distance, as well as finding a midpoint. But as always, if you have questions as they come up, just send them my way, and I'll do everything I can to make it make sense. I appreciate you taking the time to watch this video, and we'll catch you next time.